that will be ever so slightly different today is that I'm going to introduce you guys to a couple of things. One of them, I know you know how to do, and that's the angle of elevation stuff. But the other one is the reciprocal trig functions. So just want to kind of run through those real quick. Work through a few of those, how do we set those things up, how do we solve for these other five trig functions. You can get one trig function, how do you work with those besides, and go from there. So back to the good old-fashioned SOHCAHTOA stuff. Yesterday we dealt with these things, okay? And what we did was, we all know that SOHCAHTOA, all the sine, cosine, tangent, opposites, adjacents, hypotenuse, are all dependent upon perspective. You guys understand what I mean by perspective? Yeah. Remember, it's like which angle are you working with? So what we were doing was really pretty simple. Any kind of right triangle, draw it out. Depending upon where you place your theta. If I place my theta here, this is my opposite, this is my adjacent, and this is my hypotenuse. Whereas if I place the theta in the other spot, the opposite, adjacent, flip-flop. Then again, that's nothing new. You guys all knew that. All right?
Good morning, Barb. Today is Friday, February 14th, 2020.
In case you didn't know. Yeah, I can't wear red. I want black. And I probably should remember that it's like his birthday. He was born on Valentine's Day, so he's his birthday. No, we traditionally, one of the things my wife has always done is she's always crepe papered their doors and put balloons into the open door and it all falls on and stuff like that. But no, Connor will get his tickets to Pearl Jam tonight as a surprise. He's gonna be very excited. He's gonna flip. He's gonna absolutely flip.
You like Shamrock Shakes? You know, they're like, come out in a week, but like, you can go to the McDonald's and get them.
Oh, they're
Wait, for real?
Yeah, I got one here. Look, yeah, I got one here.
What? Okay.
You just go to Culver's and get an Oreo one.
It's not the same.
I mean, I'd say we just go take a field trip, but you're not always gonna fit in my truck.
You can put it all in white mud.
Anyway, it is a 6.5 foot bed. You're all kind of short.
Peter has a car.
Yeah, Peter, you're driving.
Peter can hotwire the car. Peter can drive this.
What was the Peter's car?
I'd like to survive. Anyway, it's safer there. So yesterday, real quick, guys, but one of the things that you guys did, you probably did last year in terms of sines, cosines, and tangents, is you probably worked with some of the side lengths, how to find the other sides given one. For example, if I say that you have the side of theta is 3 over 5, what would that look like? A triangle, very good. What's the opposite? 3, and what's the hypotenuse? Okay, so if I draw it like this, I mean, does it matter where I put theta, honestly? Could we just say, not draw on the scale? If you had to. So, but obviously this side looks shorter than that one, but whatever. So I place theta here. This is my what? Opposite, which means this is 3. This is my hypotenuse. Okay, what's missing? Jason, what is it? 4. Very good. So if I knew the 3 and the 5, Could you therefore tell me what the cosine of theta was? What the tangent of theta was? Yeah, what's the cosine of that theta? 4/5. Tangent theta would then have been 3/4, okay? And that's where this stuff came from, okay? So did you guys do it that way last year at all? I wasn't sure, because it really depends. I don't think in geometry we really worry about the placement of these values as much as we will see as we go forward in this one, in Algebra 2. We do a lot more of this about a week or so when we start talking about placing things on the coordinate plane to find different values of theta. But for right now, I just wanted to remind you that when you place a theta value, if they're giving you a ratio, that just means those are the side lengths, 3/5. This is how you would have set it up to find theta, then to find the actual angle value. And then you do your inverse trig function and on and on. Now, what's going to happen here today is I'm going to show you guys that there are more than the 3 trig functions. You guys are accustomed to sine, cosine, and tangent. But guess what? There's more. I'm gonna double your trig knowledge.
Wow.
These are what we call reciprocal trig functions. Okay? The reciprocal trig functions are just that, flipped. It is cosecant, CSC, secant, and cotangent. All right, so this is cosecant, secant, and cotangent. Basically what happens here is that if you do the reciprocal, everything flips. Yes, ma'am? Secant you did last year with circles went something through. So when you had a circle, a secant to a circle was the line that went through it. Remember that? Because if you think about it, it's secant destroys the circle because it kills it.
I remember the term. I didn't think of what it means.
Yeah. Oh, Mike.
All
right, never mind that. Okay. That's and this the secant portion here of the circle. It really doesn't matter. It doesn't make any sense to the triangle stuff. Like, okay. So what we have here are what we call reciprocal trig functions. Reciprocal trig functions are just that. They're the regular trig functions just flipped. Okay. So a lot of times, we'll get to that here. If we say 1 over sine, that equals cosecant. A lot of times with these things, I won't put a theta next to it when I'm writing out definitions, just because it gets a little messy. Just remember that you're talking about an angle, you're talking about an x, you're talking about a theta, something like that. I normally just don't put it there. It's just me, no big deal. It's not you, it's me. And then also, if you think of it this way, 1 over cosecant equals sine. So if you flip them back and forth, that's how you get the reciprocal functions. Okay. Cosecant, it's if you do the reciprocal of sine, you get cosecant. This becomes a lot more prevalent when we start talking about graphs. Okay. If you put your pencils down for 1 second. What happens in graphs, if we're talking about sine, for example, sine starts at 0, it ends at 2 pi. Halfway between them is pi. Halfway between those are pi over 2, 3 pi over 2. Sine values are never greater than 1, and they're never less than negative 1. So sine starts at 0, goes here, and it does this. Okay? When you reciprocal those values, it flips. So what's the reciprocal of 0? No, 1 over 0. What's the reciprocal of 0? Think about slopes. What's the reciprocal of the slope of 0? It's not horizontal, it's now, which means it's undefined. So at zeros, you get undefined. Okay. What's the reciprocal of 1? 1. Okay, so that stays the same. What's the reciprocal of negative 1? flip it, still becomes -1, okay? Do you guys agree that somewhere between 0 and 1 is 1/2?
Yeah.
What's the reciprocal of 1/2?
2.
2. Did that occur also here? What's the reciprocal of -1/2? And then, so what happens is you get reciprocal graphs that do that. So they flip off of one another. So reciprocal trig functions are just literally, instead of opposite over hypotenuse, hypotenuse over opposite.
I don't like
It's extremely visual and it's extremely straightforward as we get to this part here. All I want you to understand for right now is what these things mean. Cosecant is just sine flipped. Secant is cosine flipped. Cotangent is tangent flipped. It will take a little bit of time to get used to seeing the CSC for sine, because you want to think that's cosine stuff, the C value, okay? It's just one of those weird things you get used to, okay? But as we go from there. So what'll happen here is that I can ask you guys, I had one written down. What's the So if I say that the find tangent of theta if cosecant theta is 5/4. Of course, I use another number we just used, okay? So again, the easiest thing to do, draw it out, exactly. Right, remember, trig is probably the most visual. If it's not just trig or conic sections, take it up. Write this down, don't play on your video games. Okay? This is so visual. Okay? Place of theta. Obviously, you don't place theta where the right angle is. Okay? Doesn't matter which other side you place it, because if you're placing theta up top, you're still talking about opposite hypotenuse. It's your perspective. It's what you are looking at. Okay? Cosecant is the reciprocal of sine. So if sine is opposite over hypotenuse, cosecant would be hypotenuse. So I know this is hypotenuse opposite. So according to my diagram, my hypotenuse is 5, my opposite is 4. What am I missing? 3. So what's your tangent of that value? 4/3. Okay. That's where this comes into play. Not terrible? Yes, ma'am. They don't show up as often as you think. The most common ones you're gonna see are the 3, 4, 5, and then the iterations of that, 6, 8, 10. 6, 8, 10? Yeah, 6, 8, 10, I forgot that. And then the other one usually that I see a lot of is 5, 12, 13s. Because in worst case scenario, what could you always do? Okay, and if it winds up being a triple, you just went with a clean number, and it just took you 5 seconds longer than somebody else to do it. So it's not the end of the world. Okay, let's try another one like that. Let's see what was the other one here. Same basic idea. Let's find the sine of theta if cotangent of theta is 3. Okay. So again, cotangent is the reciprocal function of what? Tangent. So if tangent is opposite over adjacent, cotangent would be adjacent over opposite. So what's your adjacent for cotangent in this case? 3. And what's your opposite? 1. So this is your 3, this is your 1. Now what do you do to find your hypotenuse? Factor through. Okay. In this case here, you get 3 squared, which is 1 squared is 1 plus 9 is what's the square root of 10? Now, sine is what over what? Very good, very good. So your sine then equals 1 over root 10, which means you have to do what? Rationalize. So you multiply top and bottom by the root 10. So your sine of theta becomes root 10 over 10. Again, you're gonna be using Pythagorean theorem a lot, stuff like this, and it just kind of falls back into place. Right? It just kind of falls back in. Maybe there's any other weird ones. Oh, I'll throw this one in. All right. Cosine, if tangent of theta is 3 root 7. Okay. Tangent's 1 over what? Okay. So place of theta, right angle, opposite, 3 root 7, adjacent, that is 1. Do you remember how to square when you have radicals? Be careful with it, okay? You've got a number up front, just square it. What's 3 squared? What's 9 times 7? That's how you do it. Okay. When you're squaring stuff like this, if you want to do it by hand, think of it this way. You're still doing 3 root 7 squared. If you did that in a calculator, what would you have to remember to put around everything? Parentheses, okay? But if you think about it in terms of knowing how to math, it's 3 squared and the square root of 7 squared. Square root of 7 squared is 7. 3 squared is 9. 9 times 7 is 64. So, 63. Sorry, I was getting ahead of myself. So 63 plus 1 squared is? And square root of 64 is?
8.
Wow.
See, a lot of this stuff works out pretty clean. SMRT. So that gives me my cosine value of 1/8.
1/8.
Okay. Not terrible? That's not too bad for something new, is it?
No.
No? Okay. Now, what about this other bit here? This other last little bit is what we call good old-fashioned. It's not.
No, I never got these right. I never really wanted that at all. I didn't listen to
Sorry.
it.
So, angles of elevation, angles of depression, they are basically the exact same thing because they are the exact same thing. This is what we call, I think of angle of elevation. You guys ever heard the term called line of sight? Line of sight looking up is angle of elevation. Line of sight looking down is angle of depression. That's the easiest way to think of it. Okay. What's that?
What's that supposed to be up with the depression?
Up there, it's a kite.
Oh,
That's the street.
Ah.
I read a book about it.
Can we zoom in a little bit?
It looks like a boat.
I thought
I never got it. I would have like a trip for like 2 days, then
You know, my kids get kites all the time. They last for like 2 days. You're right, they last for 2 days, and then they break or the strings snap, but they never throw them away. I was putting stuff away last fall, just clearing out the garage, making space to put the snowblower in the garage, take the lawnmower, put it out in the shed, do all this, just general maintenance, because, you know, adulting. Yeah, that sucks. But all of a sudden I found like 5 kites. Seriously, I don't ever remember buying them a single one.
I have one of those too.
That would be fun. I would enjoy that.
But see, those you actually have to like take care of.
Yeah, I'd rather pay $1 if it's like $1.50 and my kids it lasts an hour and a half.
Yeah, exactly. And where I live, we would never do any wind. Whenever I wanted to play, I would never have wind. So I would just run with it and see it.
My dog ate my
That is very sad.
We had one kite fest like that where like there was no wind.
If you could only bring a kite to school, because we never have any wind around here.
Wow, it's almost like.
So we go on the roof and fly kites.
No, that would probably be not smart. Yes, ma'am.
We all look at kites so we can learn about the angle.
If you want to go outside today and fly a kite, more power to you.
No.
Great job.
I will watch you from here and say, "This is going great." Anyway, angle of elevation, angle of depression. Think of it this way: as this guy has his axe, because why wouldn't you have an axe? And you see the clock, and you want to throw the axe at the clock because you want to stop the clock. Ooh. Sorry. So
Throwing himself.
he's one of those.
It's like when he's
The axe is
Yeah, or what was the
I didn't know it was flying too hard.
I try to think of the movie. Oh, it's like oh god, I just watched it too. Big Trouble in Little China.
Oh!
It's the bad guys in Big Trouble in Little China who just kind of float.
Oh yeah!
Never seen it?
I'm sorry, I haven't watched any good movies. My parents don't culture me.
All right, so
I am ashamed.
we have to real fast. Your list for this weekend: Big Trouble in Little China.
Yeah, I've never seen that movie either. I've never even heard of
It's kind of weird.
Yeah.
I love it. My kids love this movie. It's so great.
I
Office Space.
That's a good
hate that movie.
Honey, I Shrunk the Kids.
What was the other one we recently talked about that I was very upset you guys haven't seen? I forgot.
I thought it was Office Space.
Which one? That was Office Space.
That was Office Space.
It wasn't gambling, but it was like the how they scan the system. I think those are two good ones right now. So anyway, remember watch those over the weekend. They're good.
There will be a skill check. There will be a skill check on Monday about that.
Yeah, right.
That's our party. It's so dumb. Wait, talk a little.
Oh, that's gonna throw my sound. Anyway, so here's what happens when we get into word problems. Angle of elevation, angle of depression in this class are more or less going to be problems you just have to kind of draw a picture. Okay. Obviously, you probably can't read this. It's no big deal. Find the angle of elevation of the sun when a 12.5 meter tall telephone pole casts an 18 meter long shadow. So this is where you have to understand how things look. Shadows lie where? On the ground. Very impressive. Telephone poles.
That shadow's on the wall.
What are those?
Telephone poles are generally made of
Wood.
wood. Comes from trees grow one direction. Okay, so we're having way too much fun. But anyway, so we have the ground, we have a pole. Now, this is a tough one. Where is the sun located?
Down there.
So we have to find the sun.
Ready to go. I found the sun.
That is really good.
It looks like a dandelion.
There you go.
That's a rad dude.
That was great. That was good. That was really good. I've never heard that. That was awesome. That was a rad dude with a pad too. I like it. Anyway, so if all things go according to plan, telephone poles make what kind of an angle with the ground? Now, we're not in a hurricane, things aren't blowing over. Okay?
We're in the Midwest.
True. Anyway, so the shadow, we said it was on the ground.
Yes.
The pole was up. We need to figure out the angle of elevation. So the angle of elevation, is that this angle here, or is it this angle here?
It was the first one you drew.
Are they the same angle?
Because of opposite something. Opposite interior.
Opposite
Oh,
interior.
yeah.
So what trig function will allow you to find the angle of elevation here? Tangent. So what happens a lot of times with these, it works out to be really fast trig functions. Tangent something is 12.5 over 18. So what do you do to find theta in this case?
Inverse trig function.
Yo. What's that? Yeah. Top drawer on the right there, okay? Press some buttons, what'd you get? 2. Great. What was it? 60.6, 2 decimals though? Alright. Alright. Always go 2 decimals. Okay?
Those moments of 30-60.
So close, but yet so far. What's the other? These have too many pictures.
Why did I get 21.24?
You didn't do it.
What did I do wrong then?
Peter got it right there.
I think I heard it.